Hello all, welcome to Engineering World. So today we are going to discuss the topic of bootstrapping, that is a topic of the compiler design, and this is based on T diagrams. So let us see what is bootstrapping. The bootstrapping is used in compiler. Okay, so what is compiler here? Compiler is nothing but which converts high level language to the machine understandable language is nothing but compiler. And this bootstrapping is used to produce the self-hosting computer. What is self-hosting compiler? It is a type of compiler that can compile its own source code. It is not depending on the other. It can compile its own source code. So that is nothing but a self-hosting compiler. So this is about bootstrapping. Firstly, it is used in a compiler, and this is used to produce the self-hosting compilers, and in this self-hosting is nothing but which is used to compile the source code of its own. Okay, so let us see. This compiler can be divided into three languages. What are the three languages? The first is source language, which is nothing but initial state, and target language, which is of middle state, it is of final state, and implementation language, which we'll implement here by using some techniques. So let us see what is T diagram here. Firstly, the T diagram contains these three languages like source language, target language, and the implementation language. Okay, so the T diagram was represented in a T shape, and we can see S denotes source language, and I denotes implementation language, and T denotes target language. So in this we have the initial source code, and this is of target code, which means that this whatever it is there, firstly this source code is going to implement here whatever the errors will be there in the code, it will be rectified here in the implementation, and again this will be implemented here, and again it will be converting into the target code. So target code is nothing but a final code. Okay, so we have the some steps to produce the new language L for machine. Okay, so firstly you have to create a compiler which runs on the machine A. So what does it mean? You have to create a compiler which runs on machine A is nothing but you have to create one of the T diagram here. Okay, so they were saying to create a compiler that can run on a machine A, means this is a diagram which we are going to draw. On machine A, in place of implementation, you have to write, this is in the place of implementation, right? And this is in the place of target code. So in the target code place and the implementation place, we have a machine A, this both, and the source code was same. The source code is not changed because we are creating this compiler that will be running on the machine A. So that is T diagram. So next we have create a compiler for language L. What does it mean? For language L, in the sense you should remove the source language. It doesn't mean you have to start with the source language. You have to start with the language L, whatever the language you are starting, so you have to start with the L. Again, this language place we have the source code, right? And here we have the implementation, and here we have the target code. So here language acts as source code, and this will be acting as a implementation code, and this will be as a target code. So whatever the machine A, it will be the target code, means in the machine A we are going to produce this target code, and again in the source we are going to implement this source code, and again we are using a particular language to implement this source code. And in the step 3, this is a final step. Here you have to compile both and create a compiler for language. In the first step you have created a compiler for machine A, and in the second step you have created a compiler for language L. So in the third step you have to combine this both. After combining this both, again you have to create the compiler for language L. Okay, so firstly I have taken this here, and this language and source code, and this is of machine A. This both was running on the machine A, and I have taken, again this is the first step, whatever we have on the machine A which we did, so that we are going to take here. And again we have created one of the compiler for the language L, and this is A, this is of machine A. Also in the final step you have to combine both. So when you are going to combine this both, okay, so you will get one of the equation here. So what is the equation, we'll see. Okay, so LCS of A denotes SCA of A denotes LZA of A. So this is a final equation which we are going to get. Okay, so what does it mean here? So LCS of A in the sense you are using one of the language, and this is of source code, and this contains machine A. Okay, and in this also, firstly we have taken a source code, and again we have taken a machine A. Okay, and again this is also same. So this is a final thing. After combining we are going to get this. So firstly what we have did in the bootstrapping, so for the bootstrapping was used in a compiler. Okay, so it is used in self-hosting compiler, and it contains the three languages like source language, target language, and the implementation language. And we have seen the T diagrams. In the T diagrams we have source, implementation, and the destination, and in the three steps we have created the T diagrams. So firstly we have created a compiler that can run on machine A. So again we have created a compiler for language L, and again we have combined both, and again we created again another compiler for the language L. Finally we produce this equation. Okay, so this bootstrapping is mainly performed by the T diagrams. Okay, so bootstrapping is formed by the T diagrams. So in this way we can construct the bootstrapping in the compiler design. So thank you for watching my video. We'll meet in the next video by different topic. Thank you.